What happens when the price of a good goes up? Well, the law of demand tells us that the quantity demanded is going to go down. But this effect actually has two parts to it. There's what's called the income effect, which is because of the fact that when the price goes up, the money that you have to spend is worth less. It can buy less of the good. So your income, it's as if your income were diminished. So that's going to cause you to buy less of the good. The second effect is what's called the substitution effect. So if one of the prices goes up, but the other prices remain constant, then you're going to buy other goods rather than the good whose price went up. So you're going to substitute away from the good that got more expensive to the goods that didn't get more expensive. So that's called the substitution effect. So knowing how the overall effect is split between these two would allow us to better forecast the effects of various policies. So let's look at these in a little more detail for normal goods. So remember that the price of good 1 going up is going to cause the budget line to rotate inwards. So let's start with the price of good 1 being a half, price of good 2 being 1. And if the price of good 1 then increases from a half to 1, that's going to cause the budget line to rotate inwards from what we'll denote by capital L1 to capital L2. Now this budget line L2 is going to be twice as steep. Why is it twice as steep? Remember, the slope of a budget line is minus P1 over P2. So the slope of the original budget line is minus P1, which is a half, over P2, which is 1. So it's minus a half. The slope of the second budget line, after the increase to the price of good 1, is minus P1 prime, which is, remember, 1. So minus 1 divided by P2, which is still 1. So minus 1. So now the budget line went from having a slope of minus half to having a slope of minus 1. So it's a steeper line. So you can see that in this picture. We've demonstrated this for an income of 30. Again, how do you draw this line? It's best to start with the corners. Let's start with the corner that doesn't change. That's because the price of good 2 remains constant at 1. Since the price is 1, you could buy 30 units of it. So this intercept is going to be at 30. Now let's look at the other corner. Before the price change, the price of good 1 is a half. So if you have $30 and the price of good 1 is a half, well, you can buy 60 units of it. So this corner here is going to be at 60. After the price change, remember the new price of good 1 is 1, so you can only buy 30 units of this good since you have $30. That's if you spend all of your money on this good. And if you're buying 0 units of good 2. So this corner is going to be at 30. So when you want to draw the budget line, you just connect this corner with this corner to get line L2, and you connect this corner with this corner to get line L1. And as we see, it rotates inwards because the price of good 1 went up. So let's calculate the income and substitution effects for a given good when it's a normal good. Indeed, when we have a Cobb-Douglas utility function, both of the goods are normal goods. So let's remember that the demand functions for the two goods are given by these expressions. Remember, this is Q1 to the A, Q2 to the 1 minus A, where A is 0.4. And so the demand for good 1 is going to be A times Y divided by P1. So A is 0.4, so it's 0.4Y divided by P1. So the quantity that you're going to demand at these given prices before the price increase, remember the price of good 1 is a half, you've got $30. So 0.4 times 30 divided by 0.5, that's 24. Similarly, your demand for good 2 is 0.6, which is 1 minus a, times y divided by p2. Y is 30, p2 is 1. You plug those in, you get 0.6 times 30 divided by 1. That's equal to 18. So the bundle that you demand is 24.18. That's before the increase to the price of good 1. What happens when the price of good 1 goes up? Well, you're going to demand this bundle Q1 prime, Q2 prime. So what's the new demand? Again, your demand for good 1 is 0.4y divided by the price of good 1. But now the price of good 1 is 1 instead of a half. So we plug that in here. So 0.4 times y, which is 30, divided by p1 prime, which is 1, and we get 12. The quantity of good 2 that you're going to demand is 0.6 times y divided by p2, because the price of good 2 didn't change. So 0.6 times 30 divided by 1, which is, again, 18. So you're going to demand the bundle 12.18 after the price increase. So when the price of good 1 went from a half to 1, the quantity demanded went from 24 to 12. Of course, that confirms the law of demand, and we see a decrease of 12 units. So the total effect of the price increase from a half to 1 is 12 units of decrease to the quantity demanded. What we're going to do now is see how that breaks up into the substitution and income effects. So if we draw a picture, remember we had drawn the two budget lines. That's after the change, and that's before the change. We've got those two budget lines. And we have to ask the consumer to pick their best bundle before and after. And we did the math, and we found that the best bundle before the change is 24.18, and the best bundle after the change is 12.18. So we see that there's a total effect of 12 units. What we're going to do is we're going to split that 12 into two different parts, the substitution effect and the income effect. How are we going to calculate the substitution effect? Well, let's do the following. This is a hypothetical. It's a thought experiment. Let's suppose we gave at these new prices, we're going to increase the income of the consumer so that they come back to their original indifference curve. Remember, this is the indifference curve that they started out at before the price went up, I1. That's their original indifference curve. What we want to do is increase their budget, increase their income so that they go from this bundle to some bundle that's on the same indifference curve, like E star. So we're going to just give money back. So we increase the price of good 1, but then we're going to give money back to the consumer so that he can get back to the original indifference curve. So he's indifferent between the bundle he ends up with at the new prices and the bundle he started with at the old prices. And the reason he's indifferent, he doesn't mind the increase in the price, is because we gave him extra money. In this particular example, we've given him about $10. And if you did the math, you'd find that and we'll do that later, when you do the math, you'll find that if you give this consumer more money to bring them back to this indifference curve I1, they're going to consume a bundle E star such that they consume 16 units of good 1. So the substitution effect is going to be the difference between 24 and 16, and the income effect is going to be the difference between 16 and 12. So finding this E star tells us how to break up the total effect between the substitution and the income effect. Now you might wonder, how the heck did we find out that we needed to give him $10 more to get him from 30 to 40 in order to bring them back to this indifference curve I1? Well, let's look at that. What we're going to do is first calculate the consumer's utility at the original prices. Before the prices went up, what was the utility of the consumer? Well, remember the consumer was consuming the bundle 24.18. So we can just plug that into their utility function and calculate their utility as being 30 times 0.8 to the 0.4 times, this should be a 0.6. 0.6 to the 0.6. Now, let's suppose their income were Y. We don't know what Y is. We're going to solve for Y. Let's say they had an income of Y. If they had an income of Y, what bundle would they demand if the prices were the new prices? Remember, these are the old prices. But now we're going to consider what happens if we suppose that they have this income Y and the prices are P1 prime and Q1. Well, remember P1 prime is 1. So the consumer is going to demand 0.4 times Y of good 1, and they're going to demand 0.6 times Y of good 2. So if their income were Y and the prices were the new prices, they would consume the bundle Q1 star, Q2 star, and their utility, just plugging into their utility function, would be Y times 0.4 to the 0.4 times 0.6 to the 0.6. Now what we want to do is find the Y such that they're indifferent, they're on the same indifference curve at the new prices with income Y and at the old prices at their original income of 30. So that's what we're going to do. Right? So we're going to say if they have the same utility at the new income and prices to what they had at the old income and prices. So this is the utility at the old income and prices. This is the utility at the new income and prices. Well, this comes from here. This comes from here. Notice here I've just factored out the 2 to the 0.4 from this thing. We'll just cancel out these two. 0.4 to the 0.4, 0.6 to the 0.6. So we then see that Y is equal to 30 times 2 to the 0.4. Well, if you plug that into your calculator, you'll find that 30 times 2 to the 0.4 is 39.5852 blah blah blah, which is roughly 40. And that's where we found that. So the total effect is equal to the substitution effect plus the income effect. What the substitution effect does is to cause you to move along the indifference curve that you're already on. And remember, the slope of your indifference curve changes as we move along the indifference curve. So we want to move to the point on, if there's a change in the price, we want to move along your indifference curve so we get to the same slope as the budget line, the new budget line. The income effect causes you to move to a lower indifference curve. So for normal goods, this means that you're going to consume less as the price rises. On the other hand, for inferior goods, the income effect is actually going to have the opposite sign, right? Because as your income decreases, you're going to consume more of this good. So for most goods, the substitution effect is higher than the income effect. So in that case, the total effect is going to have the right direction. Remember, the total effect is equal to substitution effect plus income effect. Now, if substitution effect, so substitution effect is going to decrease. If the price goes up, substitution effect is going to cause the quantity demanded to decrease. But if we have an inferior good, the income effect is going to cause the amount demanded to increase. So as long as the substitution effect is bigger, the total effect is going to be that we decrease the amount of the good that we're going to consume. So that confirms the law of demand. However, and this is not something that we observe in reality, but it's theoretically possible that the income effect could be bigger than the substitution effect. So you could have instead this relationship. Again, there aren't any good examples in practice for this, but it's theoretically possible that you could have a greater income effect than a substitution effect, in which case you would actually see that the total effect would have the wrong direction. So you would actually see an upward sloping demand curve. That would violate the law of demand. Now, the law of demand is an empirical observation. There's hardly any real-world examples of these goods that where the income effect is bigger than the substitution effect for an inferior good. These goods, by the way, are called Giffen goods, but we never see these in practice, and we shouldn't really worry ourselves too much about them. But it is theoretically possible that you could have an upward sloping demand curve. So it's important to remember that the law of demand is an empirical observation. It's something that we see in practice. It's something that we mostly observe. And so for the most part, we can just make this assumption that demand curves are downward sloping.